Question 13. This question is a sufficient assumption question, and we know that because the question stem says that the conclusion of the argument follows logically if which of the following is assumed. So on a sufficient assumption question, the correct answer is going to be a new piece of information, an extra piece of evidence that when we add it to the evidence that we've already been given in the stimulus, will prove the conclusion true beyond the shadow of a doubt. 100% it will be sufficient to prove the conclusion. Accordingly, we have to start out by looking for the conclusion. Here, it's not hard to find. It has a nice conclusory keyword. It follows that right in front of it. So the conclusion is M contains twice as many cans as L. Now we have to read back up to figure out what they're talking about with M and L. So apparently M is a group of standard aluminum soft drink cans. L is another group of used standard aluminum soft drink cans. So the relationship between them is they took L's material, L's aluminum, recycled it, and that became 50% of the aluminum that makes up group M. Now the remaining evidence is essentially a bunch of loophole closers. We get two pieces of evidence that are highlighted with the evidence keyword since. Since all the cans in L were recycled into cans in M. In other words, they didn't drop any. Everything that was in L went into M. And since the amount of material other than aluminum in an aluminum can is negligible, in other words, there's nothing but aluminum in the cans. You don't need magnesium or tungsten. And then that first sentence, standard aluminum soft drink cans don't vary in the amount of aluminum they contain. So if it takes 30 milligrams of aluminum to make one aluminum can, it doesn't take 50 to make another. Whatever the amount is, it's the same for all the cans. Now, this question is a little bit tricky because it might seem like all the loopholes have been closed down, that essentially they've proven their point. All the material from L went into M or got recycled to go into M. You don't need anything other than aluminum to make a can. All cans have the same amount of aluminum in them, and by volume, 50% or half of M's aluminum came from L's aluminum when it was recycled. So what is there left to prove? Now, there has to be something left to prove, otherwise this couldn't be a question. If the conclusion were already proven, then the answer to the question, what do you need to add to prove this, would be nothing. But they never give us nothing as an answer choice. The only real question I would have here is about the recycling process. All the cans in L were recycled into cans in M, but when you recycle aluminum, do you get all of the aluminum? If it takes 2 cans worth of aluminum when you run it through the recycling process because of washing and melting, I don't know all the things they do, but if it takes 2 to make 1, then maybe M isn't twice as big as L was. Sure, half of M's material comes from the recycled material from L, but that doesn't mean that it comes from the original material from L. So let's look at the answer choices and see if we can find something that, when added to what we have, closes down all possible loopholes, makes it so that, yeah, M is definitely twice as big as L. Answer choice A, the aluminum in the cans of M can't be recycled further. Well, what happens to M after we've made it is really beyond the scope of the argument. This argument is trying to prove what M is made up of now. What happens to M when it's M's turn to go to the recycling plant is irrelevant. It won't help us prove the size of M right now. Now B, recycled aluminum is of poorer quality than unrecycled aluminum. Well, quality isn't really an issue here in this argument. It's amount. The amount of aluminum that it takes to make a can and the amount of cans in M versus L. This won't help us prove our conclusion. Answer choice C, all of the aluminum in an aluminum can is recovered when the can is recycled. Now this is our loophole closer. If you don't lose any aluminum in the recycling process, and so if you don't lose any aluminum in the recycling process, and everything from L makes up half of M, that means there's another half of M that comes from somewhere else. 2 halves versus 1 half. M is twice as big as L. Everything has been proven. As always, let's take a quick look at the other answers just to see why they're wrong. D says none of the soft drink cans in Group L had been made from recycled aluminum. Just like it doesn't matter where M's aluminum is going after we're done making M, it doesn't matter where L's aluminum came from before we made L. It's just that transition from L to M that this argument is concerned with. So answer choice E, aluminum soft drink cans are more easily recycled than are soft drink cans made from other materials. Whatever happens with non-aluminum cans is entirely outside the scope of this argument. We're just talking about the aluminum cans in N, the aluminum cans in L, how much of L made it into M, how big M is compared to L. So answer choice E is completely irrelevant, and C is our answer.